Hi students, welcome to my lectures on mechanical unit operations. Pressure plays a very important role in industry. One has to be careful while performing the reactions so you can avoid explosions. Today I am going to give you an example that if you conduct a reaction in a closed container, how much pressure it is going to generate inside the container. Virtually we will do. Example, I have some half liter of bottle with me. I have added few grams, negligible grams of calcium carbonate into this bottle and I closed the container. If I start heating the container, the calcium carbonate will be decomposed to form calcium oxide and carbon dioxide. If complete decomposition happened, example, all the calcium carbonate has been converted to CaO and CO2. In such cases, how much amount of pressure that is going to get created in this bottle? That is what the example. It's a simple decomposition reaction we are trying to conduct, and let us see how much pressure is going to get generated inside this container if I decompose calcium carbonate completely into CaO and CO2. Okay. Initial condition, let us have, I have two containers, same the container, this is the initial and this is the final position. In the initial condition, I have simply added few 2 grams of calcium carbonate into the system. The pressure, because the moment I close the container, it is filled up with the 1 atmospheric pressure. The temperature is the normal room temperature, that is why the initial conditions for the reaction is pressure is 1 atmosphere, volume is half liter bottle, temperature is 25 degrees centigrade and 2 grams of calcium carbonate and few amount of air is present. Air will be filled up with the rest of the container. I have calculated, I will show you how I have calculated also. The initial moles of air in the container is 0.02 moles. So after the reaction, if I start heating this, calcium carbonate will get decomposed and the pressure, because CO2 will produce, the high pressure is going to get generated. So once I cool down this after the reaction, that is the condition number 2. After the reaction, the pressure I have calculated, it has come to 2 atmosphere. That means if I start with 1 atmosphere, after the reaction, the pressure inside the container has been raised to 2 atmosphere. The pressure is 2 atmosphere, temperature, room temperature, volume, bottle, the volume, I am not changing the volume of the bottle. So initial volume and the final volume will remain the same. The thing is I have closed it. And N2 means after the reaction CO2 will produce, that along with the air CO2 will be there. So what are the how many moles of air will be there? Because initial condition, that is 0.02 moles of air. After the final condition, air moles will not change because it is not going to get reacted. So final moles of air is equal to 0.02 moles plus additionally 0.02 moles of CO2 is getting added because of this reaction, and 1.1 gram of calcium carbonate. Okay, because if I start with 2 grams of solid calcium carbonate, I am landed up with 1.1 of calcium carbonate plus this much amount of CO2. So I have calculated it is around 2 atmosphere. That you can observe the the pressure has been doubled ho gaya tha, and it is doubled. Okay, so if you try to open the container, there is a chance of explosion onto your face. So that is why we have to be very careful. Even though, imagine I have started with 2 grams of calcium carbonate in this half liter bottle. After the reaction, the pressure is doubled. The moment you try to open this, it will come onto your face. That means you have to be very careful while dealing with this kind of gaseous reactions. Okay, because gaseous products, because CO2 is a gaseous product here. So let us go the calculation one by one. Initial condition, pressure is 1 atmosphere, that means 101,325 Newton per meter square pressure. Volume is half liter, means 0.5 into 10 power minus 3 meter cube. My temperature is 25 degrees centigrade, that means 298 Kelvin. R 8.314 joule per mole Kelvin. joule is nothing but Newton meter, that means 8.314 Newton meter per mole Kelvin. So I know the ideal gas law. Let us presume that ideal gas law is valid. How many number of moles? PV equal to nRT and N is equal to P1 V1 by RT1. Substitute P value, V value, temperature value, R value, you get 0.02 moles of air is there in this container. You can neglect, because you have a very minute amount of calcium carbonate in this 1 liter bottle, you neglect the volume occupied by this calcium carbonate itself. Okay. Condition 2, after the reaction, CaCO3 solid gives rise to CaO solid plus one of the product is gas. If everything is solid, there is no much difference, no, the pressure will you are going to see, because everything is solid. If you have 2 gram of solid, you get only 2 gram of the solid at the final stage, then there is no problem. The problem is here, CaCO3 gives a solid, gives rising to CaO solid plus CO2 gas. This production of gas has caused the increase in the pressure. Okay, let us calculate. P2, I have got 2 atmospheres. After the reaction, let us see how I have got the 2 atmospheres. The moles initial occupied is the moles. Now after the reaction, the thing inside this particular container is air plus CO2. I know how much amount of air that has been trapped in the container before the reaction, 0.02 moles of air, plus in addition, because of this reaction, 0.02 moles of CO2 has been added into the system. I know the volume is not changing because I have only one, I have tightly capped it so that nothing got escapes and nothing comes in. So the volume is constant here. So the V2, this is V2, I'm just a small, I'll check, this is V2. Initial volume and final volume are the same, because 0.5 into 10 power minus 3 meter cube. Temperature, because I have cooled down the gun. After the reaction, there might happens, the temperature might have risen up. What I do after the reaction, I cooled it down to room temperature. Okay, then I have started measuring the pressure. T2 is 298 Kelvin, same room temperature. R is the same, and this is what the reaction comes in. According to this reaction, 1 mole of CaCO3 gives 1 mole of Ca2 and 1 mole of CaO. That is what 1 mole of CaCO3 solid gives rise to 1 mole CaO, calcium oxide solid here, and 1 mole of the CO2 in the gas. Let us calculate how many moles. Let us see how these moles have come. Mass of CaCO3 I have taken, initial condition is 2 grams. So 2 grams. Molar weight of calcium carbonate, you know, 100 gram per mole. So moles of CaCO3 in this 2 grams of CaCO3 is weight by molecular weight. 2 grams divided by molecular weight is in gram per mole. Gram get cancels out, the mole comes here. That means 0.03 moles of CO2 is produced, 0.02 moles of calcium carbonate. That means 2 grams of calcium carbonate will be equal to 0.02 moles of CaCO3. Let us go. I know from this reaction 1 mole of CaCO3 gives rise to 1 mole of CO2. 1 mole of CaCO3 will produce 1 mole of CO2. Then 0.02 mole of CaCO3 will produce 0.02 mole of CO2. Now imagine earlier it is only air, that is 0.02 moles of air. Now it has been added by again 0.02 moles of CO2. Then what is my total moles? That is moles of air plus moles of CO2. The moles of air is 0.02 plus 0.02 plus is equal to 0.04 moles. That means in total, in this, after the reaction, the mole has been doubled. Because of this doubling of moles, what happens to the pressure? Let us see. V1 equal to V2. That means the volume before the reaction and after the reactions remains the same. Then as for the ideal gas law, we know V is equal to nRT by P. Okay, V1 N1 RT1 by P1. Second condition, N2 RT2 by P2. We know the temperature, initial temperature and final final temperature is the same, and R is the same, and you get P2 is equal to RR get cancels out, T2 T1 get cancels out. Now P2 is equal to N2 by N1 into P1. My N2 is equal to 0.04 divided by 0.02. into P1. What is my initial pressure? P1 is 1 atmosphere, which is 101325 Newton per meter square. Now, if you substitute all, then you get P2 is equal to 202650 Newton per meter square. That is nothing but, in terms of atmospheres, that is 2 atmosphere. You have started with 1 atmosphere, you have ended up with 1 atmosphere because of minute reaction that happened in the mixture, which is 2 grams. 2 grams of calcium carbonate has caused the rise in the pressure, 1 to 2 atmospheres. So, please be careful with the reactions. Maybe sometimes students, a bit casual in performing the experiments. They want to try out what happens if I close the container, add some things, I heat a few things, what is going to happen? It is caused some danger to them. So, always make sure that the reactions containing gaseous components, products of gaseous components like the CO2 in our case, it will, the more is the moles that is produced, the more is the pressure it is going to generate in the container. So, this is what I hope you have learned. We will come up with a new video. Thank you.